Okay, in geometry today, we're looking at good definitions, and we're going to focus on points, lines, and planes. So a good definition can help you identify or maybe classify an object. So stop and think about what makes up a good definition, okay? When you're telling me what something is, what is going to make it a good definition where I really understand what you're talking about? Well, the first thing would be to use clearly understood terms. Oh, sorry about that. Let me get the right tool. Use clearly understood terms. These terms should be common, that we use all the time, or maybe previously defined that we've already used throughout the year. You want to make sure that the words you use in the definition are words that people are going to know what they mean. A good definition is precise. In other words, you don't want to use words like large or sort of or some or a few. You want to be very precise, very specific, okay? And the last thing that makes a good definition is that it states what the term is rather than what it is not. So states what term is rather than what it is not. Okay, so looking at number one, the figures in group one are rectangles. So if you look at this group, they're all rectangles. Now think about what a rectangle is, okay? The figures in group two are not rectangles. So these are not. So look at those and see if you can tell maybe what they're not. So from group three, select a figure that is a rectangle. You got to read carefully. Which one of these in group three would be a rectangle? A, B, C, or D? And your answer is D. Okay, this one is a rectangle. So now that we've seen a group of, yes, they are rectangles, and a group of, no, they're not, and we picked one out, write a good definition of a rectangle. Something that it very precisely and with words we understand explains what a rectangle is. Okay, so a rectangle is okay, think about it. What do these all have in common? How many sides do they have? Okay, so it is a four-sided figure. Is that enough information? Well, probably not, because right here we have a four-sided one that's not a rectangle. So it's a four-sided shape with four right angles. Sorry about the handwriting. You'll just work with me for the first week, okay? So every one of these angles is right. Every one of them on every corner. So a rectangle is a four-sided figure with four right angles. That is a good definition. Moving down to number two, the figures in group one are zoids, and the figures in group two are not zoids. So look at group three and select the figure that is a zoid. So take a minute and look at them. See what you notice, what things they have in common, what things they don't. And I want you to pick the one that is a zoid. So look at A. Is A a zoid? I'm going to say no, and this is where I'm ruling it out. See how the tail just all comes to a point? Let's look at B and see, is that a zoid? Well, does the tail look the same as all of the zoids? Yes. Does the head look somewhat similar? Yes. So I'm thinking that looks good. Let's look at C. Does the tail look right? Looks okay. But look at the head. Okay, it does not look the same as the ones in group one. And look at D. What keeps it from being a zoid? If you look at the tail, it does not look like group one. So your answer here is B. So now, what is a good definition of a zoid? So a zooid is we're going to call it a figure, shape, something. Let's look at the head part, okay? What made a difference as far as the head? What made these not zooids? Well, notice that this one only had 1 dot. This one had 3 dots. So all of the heads on the zooids had how many dots? 2. So a good definition would be a zooid is a figure with 2 solid dots on the head. And now let's look at the tail. Okay, tell me about the tail. Does it have 1 part, 2 parts, 3 parts? Okay, they all have 2 parts and 2 parts to the tail. Okay. Remember that we want to give specific definitions. We didn't say more than 1 parts. We didn't say some solid dots. We said 2 solid dots on the head and 2 parts to the tail. So you've got to be specific when you're doing this. All right, going to the next page. The vocabulary of geometry consists of 3 undefined terms and lots of definitions. So let's start by kind of looking at this. Think about a point, okay? What is a good definition of a point? A good definition is a location in space. A location in space is a point. When you have a drawing of a point, you're going to have a solid dot and you're going to label it, okay? You're going to call it point A, point B, point something. And then when you write it and you talk about it, it's just whatever the name was, whatever you label it as. So your notation is just A. Now a line is a set of points, sorry about the writing, that extends in 2 directions without end. Without end. Okay, think about it. What does it mean without end? It means it goes forever. So when I draw it, what means it goes forever? What do you need to draw? Okay, there's 2 ways you can draw it. You can do a line like this. Notice we do have an arrow on both ends because it goes forever. And you can just give it a name. That's an M, even though you can't tell that. Okay, the other possibility is to have it like this and have a point there, A, and a point there, and a B for that point. And so when you wrote this, you could either call this line M or AB with a line over it with arrows. It's important that when you're using the 2 points on it and you draw the line above it, that you put the arrows there, okay? So you have line M or you have line AB. A plane, okay, a plane's a little different. It's kind of harder to wrap your mind around. It is a flat surface. Important, flat surface that extends in all directions. That extends or goes in all directions without end. Without end. Okay, it's important that you understand that it has no thickness. It has no thickness. So the way you draw a plane, and they don't look like squares, they're kind of at an angle like that. You can have a letter up there that's the name of it, or you can have several dots like A, B, and C. And so you would either call this plane W, or you could call it plane ABC. Okay, we'll talk more about them later, planes, like I said, are a little harder to wrap your mind around than a point or a line, but they're very important. They're one of the basic parts of geometry, so we need to understand it. All right, so a few more definitions. We have what we call collinear points. Think about collinear. Linear means line. Co is going to be like more than one. So collinear points are points that are on the same line. Points that are on the same line. And so if you had a long line here and you had all of your little points, and my points aren't looking too good, and I apologize. Okay, I guess I could make this really big. Make a point, make a point, make a point, make a point. So that is going to be a line that has collinear points. There's no notation for that, nothing word-wise that we write. Coplanar points are going to be points that are in the same plane. Points that are in the same plane. So you draw your plane and then you make your dots. And then you can label your dots. That's point A, C, B, D, and E. Okay. Once again, there's no notation for that. And then coplanar lines are lines that are in the same plane. Lines that are in the same plane. So you draw your plane. Notice it can tilt either way. And you have a line, and you have more lines. And as long as they're on that same plane, they're coplanar. Okay? So the rules of geometry consist of things called postulates and theorems. A postulate is a statement that we accept as true without proof. You don't have to prove it to me. You tell it to me, and I just know it's true. So a postulate is a statement that we accept as true without proof. You don't have to show it, you just tell me. A theorem is a statement that can be proven. I can go through steps of, well, if this happens, then this, or since this, then this, or this is going to happen because. Okay, so a theorem can be proven. A postulate, we accept it as true without a proof. So some postulates that you need to know and understand. Through any 2 points, there is exactly one line. Through any 2 points, there is exactly one line. Okay, that's your first postulate. Next one, through any 3 non-collinear points. Okay, 3 points that are not on the same line, there is exactly one plane that contains them. There is exactly one plane that contains them. That contains them. And then if 2 points lie in a plane, then the line containing those points lies in the plane. Then the line containing those points lies in the plane. Okay, these are very basic. They're very important. You're going to use them all year long. Remember, a postulate is a statement that we just accepted as true without proof. And a theorem is a statement that can be proven. These bottom 3 are postulates. There is exactly, through any 2 points, there is exactly one line. Through any 3 non-collinear points, there's exactly one plane. And if 2 points lie on a plane, then the line containing them is also on the plane. Here's a summary, and